All right, today we're going to unpack a really core concept for any Salesforce developer, Apex sharing keywords. And look, these aren't just little bits of syntax, they are the literal gatekeepers of your data. They're the foundation of security in your custom code. So yeah, let's just dive right in.
It all really boils down to this one simple question. Right out of the box, Salesforce has this incredibly sophisticated sharing model. You've got org-wide defaults, role hierarchies, all these rules, and they're all designed to control who sees what. But what happens when you start writing your own code? Exactly. How on earth does your Apex class know which rules it's supposed to follow? Does it just automatically know what the user can see, or does it have a mind of its own? Well, that is the exact problem these Apex sharing keywords were built to solve. They let you explicitly tell your code how to behave.
Okay, so first up is with sharing. The best way to think about this one is like the by-the-book officer. It's diligent, it's totally predictable, and it follows the rules to the letter. No exceptions, no workarounds.
So what does that really mean? It's simple. With sharing, forces your code to respect the context of the person who's running it. This means your code can only see and touch the exact same records that user can see through the normal Salesforce UI. It's basically security by default.
So where are you going to use this? Well, the most common scenario is pretty straightforward. Anywhere that your code is directly serving the user interface. We're talking Visualforce pages, LWC, or Aura controllers, you name it. If a user is looking at a list of records that you've queried, you absolutely want with sharing to make sure they aren't accidentally seeing data they shouldn't.
And let me be super clear about this. If you are ever in doubt, with sharing is your go-to. It is the safest, most secure, and honestly the most common choice for any code that a user is going to interact with. It's how you build trust right into your application.
But what if you need to bypass the rules? Well, that brings us to our second keyword, without sharing. If with sharing is the by-the-book officer, this is the one holding the master key. It can open any door it wants.
The magic phrase here is system context. This keyword totally elevates your code's privileges. It allows it to see and modify records no matter who is running it. The code itself becomes the trusted agent, not the user. And this is why you'll see this warning, literally everywhere. It's that whole, with great power comes great responsibility thing. When you use without sharing, you are intentionally overriding the security model you so carefully set up. You need to have a really, really good reason to do it.
And here are some of those good reasons. Think about all those system processes humming along behind the scenes. A trigger might need to roll up a number to a parent record that the user can't even see. Or maybe it needs to write an error log to a special object they don't have access to. In these cases, the logic just has to work for data integrity, so without sharing becomes necessary.
All right, so we've met the rule follower and the master key holder. Now let's meet the most nuanced of the three, inherited sharing. This one's the adaptive deputy, the chameleon. It doesn't really have its own rules. It just adapts to whatever environment it's in.
The definition is right there in the name. An inherited sharing class just looks at whatever code called it and basically asks, hey, are you running with sharing? Cool, I'll be with sharing too. Oh, you're without sharing? No problem, I'll run without sharing as well. It's incredibly dynamic.
And this just shows you exactly how it works. Let's trace it, right? If your user-facing LWC controller, which is with sharing, calls your inherited class, that class will respect all the sharing rules. But if a without sharing trigger handler calls that exact same class, it suddenly gets system-level access. It's the same code, but it has completely different behavior, all depending on the context.
This makes it absolutely perfect for building reusable utility classes. Just imagine you've got a generic service for updating records. You want to use that thing from your UI components and from your backend automation. Well, instead of writing two different versions, you just write one with inherited sharing and let it adapt. It's clean, it's efficient, and it's just plain smart design.
Okay, so we've met our three gatekeepers. Let's pull them all together for a quick side-by-side comparison, just so you can see how to make the right choice every single time. Before we get into all the little details, let's just focus on the most fundamental divide there is. It really just boils down to a simple yes or no question. Does the code enforce the user's sharing rules? With sharing says yes. Without sharing says no. Everything else kind of builds from that one core difference.
So, let's put it all together in one place. With sharing, that's your safe default for anything a user is going to see. Without sharing, that's your heavy-duty tool for back-end system logic, but you've got to use it with care. And inherited sharing, that's the flexible chameleon choice for reusable code that needs to play in both worlds. See? Each one has a clear purpose.
So here's the most crucial thing to take away from all this. These keywords give you, the developer, explicit control. Salesforce isn't going to guess what you want to do. You have to declare your intent. You're the one who decides if your code will respect the user, act like the system, or just adapt to whoever's calling it.
And that kind of leaves us with one last question for you to take with you. Next time you sit down to write an Apex class, just think about its purpose. Who is this for? What data does it really need? And will you choose the path of the user, the system, or the caller? The choice is yours.